G'day YouTube, welcome back to the Osmocom-BB tutorial series. In parts 1 and 2, we covered the practical usage of Osmocom-BB software in conjunction with a compatible 2G mobile phone. In part 3 today, we will be putting all the pieces of the puzzle together by showcasing Gsmtk. So let's start by describing what Gsmtk is exactly. As the author describes it, Gsmtk is a wrapper around Osmocom-BB for hobbyist, amateur GSM security research. I've got to be very careful how I word things moving forward. Not really sure how to say his name correctly, but Gender Harach developed the Gsmtk software in the year of 2012 for the purpose of exploiting the 2G security vulnerabilities showcased at the infamous wideband GSM sniffing talk at the 27C3 Hacker Conference. The author considers Gsmtk to be unfinished as it can really only reliably intercept SMS messages and not really phone calls. And we can see here down the bottom of the author's official website stating it needs additional engineering to accomplish that task. Here's a simple diagram of a typical workflow when using Gsmtk. We use a compatible mobile phone in conjunction with a branch of Osmocom-BB called burst-ind to capture GSM data to files on a PC. We then use Gsmtk to decode these burst files, or alternatively, we can use a binary included with Gsmtk to manually decode one burst file at a time. The decoded data is forwarded automatically to Wireshark or tshark for us to read and analyze. Wireshark's already included in Dragon OS LTS, but tshark is not. Even though tshark is not strictly required, I'll show you how to install it in the practical segment of this tutorial. So let's talk about software requirements now. As I said previously, Gsmtk is very old software, and subsequently it will not run on newer versions of Linux. So what we will need is Dragon OS LTS, as it is built upon Ubuntu 18.04. You can download that here from SourceForge. Installing it onto a physical machine or making a bootable USB thumb drive is not strictly required for this tutorial. Virtualization with VMware or VirtualBox is preferable for this tutorial, in my opinion. The second thing we will need is Gsmtk itself. I managed to compile this a long time ago and recently tried to replicate the attempt to build it and failed. So I've uploaded the compiled Gsmtk application files to Google Drive for you guys to download. But please be aware that these pre-compiled binaries will probably only work in Dragon OS Dragon OS LTS. They won't work on Dragon OS Focal X, Kali, Ubuntu, or any other Linux distributions that you may be using. To follow along with this tutorial, you strictly need Dragon OS LTS. The third item we require is burst files. These GSM burst files have an extension of .dat and contain raw GSM burst transmissions that have been captured from the downlink signal of a 2G cell tower or the uplink signal from a GSM mobile phone. To learn how to capture these files, please see part 2 of this video tutorial series. Because GSM burst files may be difficult to obtain for some people who may live in countries that have retired 2G technology, such as myself, I've uploaded a zip archive with a handful of GSM burst files for you guys to download and have a play around with. So let's talk a little bit about hardware requirements. We don't really need any additional hardware for this tutorial, but for the sake of completeness, we will say that we need a working PC with an internet connection, and it should be running a virtualized instance of Dragon OS LTS Linux. Or bare metal installation directly onto a PC's hard drive is also an acceptable way to run it. So with all that said and out of the way, I've got my obligatory video recording beer here, and we'll get stuck into it, shall we? So before we get started, we need to install a few applications from the command line interface to help us use Gsmtk correctly. The first one we will be installing is tshark, and we can install that with the following command here. So I'll just hit enter on that. And don't forget that I always write the commands I'm using in the description down below so you guys can easily copy and paste them. Next, we will configure SQLite because Gsmtk uses a SQL database to store and manage the GSM data that we are decoding. I'm fairly certain that SQLite and its dependencies are already pre-installed in Dragon OS LTS, so I'll skip directly to the configuration procedure by running the following command. So I'll copy and paste this and hit enter on that. So it'll prompt us to answer yes. So we'll type yes and press the enter key on our keyboard. It will then prompt us again and we type sudo and hit enter. We then send it the following command, which I'll copy and paste once again and hit enter on that. So this probably will take a little bit, so I'll have another sip of beer. So Dragon OS LTS already has SQLite installed, but I believe it needs an additional module so we can use Gsmtk correctly. I'm led to believe Gsmtk stores all the guessing and cracking information needed if we were going to pair Kraken up with this tool. I don't think it's necessarily required for this tutorial, but we'll just do it anyway. Oh, I thought it froze just then. Good. I've tried to record this video so many times now. I'm going to be very happy once this Osmocom-BB tutorial series is behind me. If you don't really know, Osmocom-BB is very challenging to work with. It's not as polished and refined as GRGSM. Okay, so that looks like it's been completed, so that's a good sign. So finally we'll type exit and hit enter. So that's the configuration of SQLite complete. Now we will install an SQL database browser with a GUI or GUI so we can browse the database files that Gsmtk creates. This step isn't really required for actually using Gsmtk, but more so it's just a curiosity of mine to see what Gsmtk is doing behind the scenes. So we need to run the following command to add the repositories of the next tool we are going to download into our package manager. So I'll just hit enter on that. This is probably going to take a while because it's updating the apt list. To all the Aussies watching this video, yes, I'm drinking 4X Gold, unfortunately. It's all I had in the fridge. It's not the best beer on the planet, as most people, Aussies, will know. Okay, cool. It's just about to finish. Great. So now I'll copy and paste the next command to install SQLitebrowser, which is a GUI SQL database browser. So I'll just hit enter on that. Okay, that's finished successfully. So that's all the preparation and configuration we have to do for the database side of Gsmtk. Let's move on to the actual installation of it. We will reopen the browser and proceed to download the Gsmtk zip archive. So yeah, I'll just proceed to download this. I think the standard installation of Firefox will download files to the downloads folder. So yeah, you might have to just browse to find them. I'll just save it directly to my home directory. Now, I do understand that downloading pre-compiled binaries from Script Kiddie on YouTube could be dangerous. So in order to alleviate your suspicions, I've uploaded the zip archive of Gsmtk to VirusTotal. And here are the results. The VirusTotal website wouldn't render on this old version of Firefox, so this is a screenshot. The link to the report will be in the description down below. And I also scanned the Gsmtk zip file with ESET Smart Security on my Windows 10 PC. I won't bother scanning the burst files because they only contain binary ones and zeros of the raw GSM bursts. So I'll minimize the browser again, and we'll locate where our browser has downloaded the Gsmtk zip file to. We'll double click on it. Sorry about that, guys. I'm back. I figured out that Ubuntu really doesn't like, or Dragon OS LTS really doesn't like you to drag folders from there and then drop them or past that area of the sidebar of the browser. So don't do that. So what I'll do is I'll drag it down below like this up into my home directory to extract the Gsmtk zip folder. So we can close this now. And I'll just try and find where I was in our script, because I'm not yet a super cool YouTuber and do stuff directly off the top of my head. Okay. All right, we're back in control now. So what we'll do now is we need to run the following command. So if you haven't done so already, just write cd, just in case you've changed directory into another place, on your computer. And we copy and paste the following command and we run that. So this command will copy a hidden configuration folder into our home directory. So we'll just hit enter on that. So next, we need to configure routing for Gsmtk so that the decoded 2G packets are forwarded to Wireshark or tshark on a UDP port of 4729. So we'll just run the following two commands. So that's the first one. And this is the second one. I always configure my Dragon OS installations to never ask me for a sudo password, but yours may do that. So just always enter your password if prompted. So now we need to add the Gsmtk bash scripts and binaries to our system's path, so we can run them directly within the terminal window without needing to cd into the Gsmtk folder. So to do that, we'll just run the following command and enter our password if prompted. And that will open up a text editor. And we'll scroll right down to the bottom. Put a few line spaces there and copy and paste the following into the very bottom of the document. And then we'll hit File and then Save and then close this document. And we'll just close our terminal window and reopen it again. So that was a lot of mucking around, but Gsmtk is finally installed and we can now proceed to the practical usage segment of the video. So before we can use Gsmtk for anything, we are going to need to acquire some burst files. Burst files are the storage method and file format used by Osmocom-BB burst IND branch. And we will use that for recording GSM data onto a PC. They can range in size from a few kilobytes to several hundred kilobytes and have a .dat file extension. So I'll just reopen my browser again. And just again, I'll just reiterate again that if you want to learn how to capture these burst files, please see part 2 of this tutorial series. So I've recorded a few burst files from the rogue base station running inside my simulated lab environment. So what we'll do is we'll just hit the download button on Google Drive. And again, I'll save the file to my home directory. And just remember that your installation of Dragon OS LTS will probably download all files by default to your downloads folder. Okay, so now I'll just proceed to open up the burst files. Actually, no, I won't. I'll do it like this. Oh no, just leave the zip folder in there for now. Sorry, guys. Okay, now comes the fun part. We're actually going to use Gsmtk finally after almost 20 minutes. Don't worry, guys, we're getting there. So, first, we'll need to create the working directory for Gsmtk by running the following command. mkdir for make directory, space, and then tk test, and then hit enter on that. And we can see that a folder called tk test has been created in our home directory. So far, so good. Now we will use the cd command, change directory, to enter the tk test folder. And in our file browser, we'll enter the tk test file directory so we can see what Gsmtk is doing behind the scenes. And then to initialize Gsmtk, we write the following command, tkinit.sh. And we can see that a number of folders and files have been created. Now we have to give Gsmtk some burst files to decode. So first, I'll open up another file browser window. And I'll locate where Firefox downloaded the burst files archive to. We'll double click to open the archive. And we need to highlight all the burst files by holding Shift and clicking the bottom one and the top one. And we need to drag them over to the new directory. And just remember not to drag the files past this sidebar because Dragon OS LTS will have a meltdown. So I'll just enter the new folder to ensure that the files copied correctly, and that's all good. So next, we will run the following command to add the burst files into Gsmtk's database. I write tk add, one word, .sh. And additionally, Gsmtk can build a statistics database from the catalog burst files we just added. So we'll run this command to do that. I'll have to copy and paste this one because it's a bit of a mouthful. Paste that there and hit enter. So this is going to take a little while, so I'll have another sip of beer. We can see that some things are happening here, or Gsmtk does its thing. These files here are supposedly the downlink voice audio and the uplink voice audio, but Gsmtk can only decode AMR. Not very well, I'm led to believe. So despite voice audio being written to this file, my test 2G cell in my lab environment only transmits voice with the GSM codec. So if I open these files, they're just going to sound like garbage and there's no point. So, all right. This next part isn't necessary for the tutorial, but if we wanted to, we can view the two SQL database files of Gsmtk using an SQLite browsing application. The first one is keys.db, and we can view it with the following command. So I'll copy and paste this command. Again, you don't have to do this, but if you're using it on a real GSM network, this could be pretty interesting. So I'll just hit enter on that. And yeah, you can go to browse data tab and there's a few bits and bobs of information there, completely irrelevant to the tutorial. But if you're using it on a real GSM base station, there might be some interesting information in here. And the second SQL database is stat.db. And we can open that with the following command. I'll copy and paste and hit enter. And go to the browse tab again. And we can see some stats about how many SDCCH frames there are, SACCH, and uplink, downlink, etc. Completely irrelevant for this tutorial, but again, could be interesting if you're using this on a real GSM base station. So I think these two database files are used for the guessing and cracking phase, but we aren't covering that in this video, so I'll just move on. So now, finally, we can run the command to decode the captured burst files. But before we do that, let's open a few additional terminal windows. And configure tshark to extract some useful information from the massive amounts of GSM data we are about to demodulate. So we'll just open up two terminal windows. So in the first one, I've got the command to extract DTAP call control messages, which will indicate if voice calls are initiated. So I'll just hit enter on that. Put a few spaces so the data is formatted neatly into the middle of the terminal window. In the second terminal window, I will run this command here to extract and display SMS messages. So I'll hit enter on that. Do line breaks to format the data neatly in the middle of the terminal window. So there's probably more useful data that we could extract, such as, dial telephone numbers and IMSI values, but I'm running out of space on my screen. So we'll just stick to these two for the purpose of the tutorial. Let's also run Wireshark's GUI in the background so we can see if Gsmtk is doing its job correctly. So I'll copy and paste this command and run that. Okay, so now the moment we have all been patiently waiting for, 26-minute mark. The actual decoding of Osmocom-BB captured burst files. So we'll run the following command. tk play one word .sh, and we'll hit enter on that. And immediately we can see that Wireshark is populating with decoded GSM packets, some SMS messages, and telephone numbers. Sorry, not telephone numbers, but DTAP call control messages are printed in these windows neatly by tshark. So yeah, that's really, really cool. Not sure why Wireshark is not displaying these messages correctly. Oh, yes, it is. Sorry. And we can see that here's all the decoded data here for us. So yeah, that's pretty cool. All right, let's talk about tk convert. The tk convert is a binary, which is a part of Gsmtk, and that's responsible for the actual demodulation and decoding of the GSM burst files. But we can utilize it to decode a single burst file with one command in the terminal window, as opposed to the regular workflow I just showcased. So if we send the tk convert binary the h argument, like so, tk convert, actually, I'll clear the console so we can focus on what we're doing correctly here. tk convert -h. And yeah, we can see all the configurable options here. So what I'll do is I will copy and paste the following command. I'll just clear the consoles of this stuff and I'll restart the Wireshark capture. And I'll just explain this command quickly. So we write the name of the binary, which is tk convert. We configure the for argument to indicate that we want to decode the SDCCH4 channel. If you guys are using this on a real GSM base station, which I highly recommend against, don't do that, that's naughty. You will most certainly be putting an 8 instead of the 4 there. So we'll configure the D argument to indicate that we don't want to perform plain text guessing. And finally, we use the F argument to specify the path and the name of the single burst file that we want to decode. So I'll just hit enter on that. And we can see that Wireshark is populating with decoded packets and the raw GSM bursts are being printed in our terminal Windows output. Pretty cool if you ask me. So yeah, We definitely need to touch on the limitations of Gsmtk though. The method I employed to install and configure it for this tutorial will not allow you to decode encrypted 2G data. Gsmtk needs to be linked to Kraken or Decca first, and additional commands need to be run to initiate the guessing and cracking attack on the A51 encrypted data. I couldn't figure out how to do this, so please don't ask me how it can be done. Thank you. Please read Gsmtk's README file for more information on linking Kraken to it and running the guessing and cracking command. I always got a database error when trying, so maybe you guys could try and figure it out. So obviously Gsmtk is broken and unfinished, as admitted by the author himself. Voice traffic decoding seems to support the AMR codec only, and only the regular GSM voice codec can be. It doesn't support the regular GSM voice codec, which is what my test rogue base stations use. And the author states that voice decoding is pretty much broken and rarely works anyway. But he has also said that Gsmtk should work well enough for reliable SMS decoding. And here's the README file, by the way. So yeah, you guys can study these couple of commands here to figure out the cracking phase. So you guys need to understand that Osmocom-BB and Gsmtk were products of a bygone era, when USB attached software-defined radios cost thousands and thousands of US dollars and were pretty much unobtainable by the general public due to the high cost of entry into the hobby. By the year of 2012, the cat was out of the bag with modifying TV receiver dongles and turning them into the infamous RTL SDR. And then nobody really cared about Osmocom-BB anymore, as cheap SDRs and AirProbe or GRGSM became the de facto method of decoding 2G. And finally, before we wrap up the video, I just want end the series and give the boring disclaimers. I just want to state very clearly that I am not the author of Osmocom-BB, the Burst IND branch, or Gsmtk itself. I didn't develop these tools, and I got them all working by simply studying the README files very carefully. Also, the author of Gsmtk has abandoned the project a long time ago and does not appreciate people emailing him asking for help with his software. So don't go bugging him, please. So yeah, this video will conclude the Osmocom-BB tutorial series for now, and I shall proceed to give my usual disclaimers. This video was made for the purposes of education and experimentation only. IMSI catching, SMS sniffing, and voice call interceptions on cellular networks is illegal and punishable by hefty fines and imprisonment. Performing practical hacking attacks on a real operating production network is a very, very silly thing to do. You will get caught and you will go to jail. Don't be an idiot and only follow my tutorial videos using a simulated lab environment. So yeah, very glad that this series is done and behind me now, because it's been very, very challenging to make, hence the long delays in getting the subsequent parts out. So yeah, very, very happy that that's done and dusted. So yeah, thanks very much for watching. Bye.